Hello everybody, my name is Love Sachdeva and I am a student in VIT Chennai. I study with the BTech branch in Computer Science Co. So today that's my introduction, and today what we are going to see is we are going to see a subtopic of a subject called blockchain and cryptocurrencies. We are going to focus on a concept which is a consensus mechanism, and it's called a proof of stake, as you can already see on the screen. So we will go through the proof of stake. First I will give you what we are going to see in this presentation. So first of all, we will see what is proof of stake, and then it will be a brief introduction of what is a proof of stake. Then we will see what is consensus, which is basically a mechanism on which proof of stake is based. So proof of stake is basically a consensus mechanism. So we will see what is consensus, then we will say how the proof of stake works, then we will compare the two consensus algorithms, proof of stake versus the proof of work. So we will see the benefits and the drawbacks and everything about these two mechanisms and why proof of stake is there basically, and why it is replacing the current proof of work. So, and then we will see the goals of proof of stake, the goals it tries to achieve, and then the security of the algorithm, and the last we will see, can Bitcoin be converted to proof of stake. So that's the basic introduction what we are going to see in the upcoming slides. So let's move on to the slides. So as you know, the first chapter is what is proof of stake and introduction to the algorithm. So we will begin by the definition. The proof of stake is a cryptocurrency consensus mechanism for processing transactions and creating new blocks in a blockchain. A consensus mechanism is a method for validating entries into a distributed database and keeping the database secure. In the case of cryptocurrency, since the database is called a blockchain, so the consensus mechanism secures the blockchain. So as we have understood by the definition, that proof of stake is a type of consensus mechanism which works basically to secure the blockchain and to make the blockchain more reliable and secure. So the key points with the proof of stakes are: the cryptocurrency owners validate block transactions based on the number of coins a validator stakes. So basically what proof of stake does is there are people called nodes called validators, and every validator stakes some amount of coin. It may be the coins which follow the proof of stake. For say Ethereum, like Ethereum follows the proof of stake mechanism, so Ethereum has validators. So each validator stakes some amount, and this amount makes the node which is behind a person a validator. So the proof of stake was created as an alternative to the proof of work, which is the original consensus algorithm which is used in Bitcoin. So it has been used till date in Bitcoin, and because of some drawbacks, now we are shifting to proof of stake for the upcoming currencies, and we will see to it. So the proof of stake was created as an alternative to the proof of work, the original consensus mechanism used to validate a blockchain and add new blocks. While proof of work mechanisms requires miners to solve cryptographic puzzles, that's the basic of proof of work, proof of stake mechanism require validator to simply hold and stake coins. As I told you, the validators hold and stake coins, and then they become the validators, which in result allows them to validate the nodes and earn the rewards. So the proof of stake is seen as a less risky in terms of the potential for an attack to the network, as it structures compensation in a way that makes attack less advantageous. I will come to that. The next block writer on the blockchain is selected at random, with higher odds being assigned to the nodes of the largest stake positions. So these are the basic key points. It is proof of stake in a gist. It is just a core. We will come in depth how it works and what are the drawbacks in the upcoming slides. So this is about what is proof of stake. Since proof of stake is a consensus algorithm, we know a bit about proof of stake. Now we will move what is a consensus mechanism, and then we will go in depth. So what is a consensus mechanism? A consensus mechanism is a fault-tolerant mechanism that is used in computers and blockchain systems to achieve the necessary agreement on a single data value or a single state of the network among distributed processes or multi-system agents such as cryptocurrencies. It is useful in record keeping, among other things. On the Bitcoin blockchain, for instance, the consensus mechanism is proof of work, as we have told you. which requires the exertion of the computational power in order to solve a difficult but arbitrary puzzle in order to keep all the nodes in the network honest. So what it does, it basically we can go by the definition only. So the it basically makes the all see there are too many nodes in the blockchain, so they all need to come to a conclusion that the transaction is valid or not. So we all do transactions with the cryptocurrencies, and to check if a transaction has been submitted or not, what we do is we use a consensus mechanism. So consensus mechanism basically takes all the validators or miners into account, and they collectively say that this transaction is right. So the consensus algorithm basically collaborates with all the miners or validators to come to a conclusion that a transaction is a right transaction or it has been a faulty one. So if it is a faulty one, it is rejected, and if it is a genuine transaction, it is accepted. So the mechanism behind it is consensus mechanism. So a consensus mechanism refers to any number of methodologies used to achieve agreement, trust, security across a decentralized computer network. In the context of blockchains and cryptocurrencies, proof of work and proof of stake are two of the most prevalent consensus mechanisms. Critics of the Bitcoin miners have argued that the proof of work is overly energy intensive, which has sparked the creation of new and more efficient mechanisms like proof of stake. So this is the gist. What is the mechanism? Public blockchains that operate as decentralized self-regulating systems work on a global scale without a single authority. They involve contribution from hundreds and thousands of participants who work on the verification and authentication of the transactions occurring on the blockchain and on the block mining. In such a dynamically changing status of the blockchain, these physically publicly shared ledgers need an efficient, fair, real-time, reliable. So what it does basically, it reiterates the point which I said before, that it comes to an agreement with the help of collective miners and validators that the current transaction is right or wrong. So coming to the how proof of stake works. So the proof of stake reduces the amount of computational work needed to verify the blockchain and transactions that keep on the blockchain, and thus a cryptocurrency secure. Proof of stake changes the way the blocks are verified using the machines of the coin's owner. The owners offer their coins as a collateral for the chance to validate blocks. Coin owners with staked coins become validators. Validators are then selected randomly to mine or validate the block. This system randomizes who get a mine rather than using a computation-based mechanism like proof of work. So basically, in the proof of work, what was happening? There were a bunch of miners. So what miners do? All you need to be a miner is you have a good powerful system to mine bitcoins. And how do we mine bitcoin? We basically mine bitcoin, it's just a gist. How do we mine bitcoin? We mine bitcoin by using by solving a hash function. So the one who solves the hash function the first is given the reward and is basically allowed to append the block in the blockchain. But since too many people are competing for one transaction, so the energy consumption is very high. It is estimated at about 0.3% of the energy is used in just mining bitcoins. So as we read earlier here, that the critics of the Bitcoin miners have argued that the proof of work is overly energy intensive, which has sparked the creation of new and more efficient mechanisms like proof of stake. So in proof of stake, what is done is there are validators, a bunch of validators. Each validators put a stake in the validating system, which is the consensus mechanism. So every person who wants to be a validator stakes some amount. So like a person Alice has staked say 50 Ethereum, and the other person, say Bob, has staked 100 Ethereum. So the minimum, the barrage for the staking is 32. Like you can only be a validator if you have 32 Ethereums. So once you deposit or stake 32 Ethereums, you are ready to be a validator. So every person who has 32 Bitcoin and is ready to stake can be a validator. So this is how the validators are chosen, and from the pool of validators, every time the ones who have staked Ethereum, one person is chosen to be the basically to allowed to validate. Well, not only one person, actually. If a block has to be mined, a group of persons, say around 100 or 128 validators, have to be selected randomly. So these validators are randomly selected, and once they are selected, they can mine the block and come to a consensus mechanism that this transaction is a valid transaction. And once the transaction is valid, the validator gets a reward. So now we come to the nuances of this. So what is done is proof of stake changes the way the blocks are verified using the mechanism. The blocks are verified using the machines of coins owners. The owners offer their coins as a collateral for the chance to validate blocks. Coin owners with the staked coins become validators. Validators are then randomly selected to mine or validate the block. This system randomizes who gets to mine rather than using a computation based mechanism like proof of work. So to become a validator, a coin owner must take a specific amount of coins. For instance, Ethereum will require 32 ETH, as I said, to be staked before a user can become a validator. Blocks are validated by more than one validator, and when a specific number of the validators verify the block is accurate, is finalized and closed, as I told you before. So different proof of stake mechanisms may use different methods for validating blocks. When Ethereum transitions to proof of stake, it will use shards for transaction submissions. A validator will verify the transactions and add them to a shard block, which requires at least 128 validators to attest to. So as I said, it requires a bunch of validators, like 128 validators, to attest that the block which has been created is a right block and the transactions are okay. So once shards are validated and the block is created, 2/3 of the validators must agree that the transaction is valid. So if there are say 9 validators, it's just a hypothetical, you can even take 300 validators. So the 2/3 will be 200. So at least 200 validators must agree that the block which has been created is a right block. So now we will come the differences between the proof of work versus the proof of stake. So as we know, we have heard a lot about the proof of work mechanism and proof of stake already. So we will see the differences and we will see what are the nuances in them. So first, the overview. Both consensus mechanisms help blockchain synchronize data, validate information, and process transactions. One is used in Bitcoin and one is used in Ethereum. There are several other which use the proof of stake like Cardano, but we will focus on Ethereum as of now. So each method has proven to be successful at maintaining a blockchain, although there are pros and cons of each. However, two algorithms have very different approaches. Under POS, blockchain creators are called validators. A validator checks the transaction, verifies activity, and votes on the outcomes and maintain records. Under proof of work, the creators called miners. Miners solve complex mathematical problems to verify transactions, which are basically hash functions, and they get the reward in return. So this is the overview. To buy into the position of becoming a block creator, investor needs only to purchase the sufficient limit of coins or tokens to require to become a validator for a proof of stake blockchain. For proof of work, miners must invest in the processing equipment and incur heavy energy charges to power the machine attempting to solve the computations. The equipment and energy cost under proof of work mechanisms are expensive, limiting access to mining and strengthening the security of the blockchain. However, proof of stake blockchains often allow more scalability due to their energy efficiency. So the basic points what we read is the proof of stake is more efficient while the proof of work is less efficient. The proof of stake is more scalable than the proof of work. Basically, the main drawback of the Bitcoin is that the number of transactions per second of the Bitcoin is very less. So in a general real world, if you want to use it, we can't, because also the cost of creating a block is very high. So if we create a block for say 10 transactions in Bitcoin, it will cost a lot, so the transaction fee will also be high. But in the proof of stake, since the block creation itself is very low, because we don't have to compete and we don't have to spend such energy, so the transaction fee is also comparatively very less than the proof of work consensus mechanism based on Bitcoin. So this is the basic difference. The other difference is obviously since we are solving a mathematical function and it is mathematically backed, it will be more secure than just making one person do the job and rest verify it. So it is not mathematical based, it is a way to save energy, so it is not that secure than proof of work, but it is still pretty secure, and it's just in comparison that it is less secure. So the main points to remember are between points of proof of stake and proof of work are blockchain creators are called validators in proof of stake and miners in proof of work. Participants must buy coins or tokens. Here we have to buy tokens and here we have to buy energy. So in one we have to buy tokens like 32 ETH in case of Ethereum, and here we just have to buy the energy equipment, and when we have all the energy equipment and all the materials to mine the Bitcoin, we can mine the Bitcoin. So energy efficiency, obviously the proof of stake is energy efficiency, we are quite familiar with it right now. So, and it is not as energy, it allows for more scalability, it allows for low scalability. Network control can be bought and robust security due to expensive upfront requirement. So validators receive transaction fee as reward in here. Basically if I validate a block, the amount of transaction fee, like if there are 10 transactions each of 100 rupees each, I might get 10 rupees from each transaction if the transaction fee is 100. Say we have transacted about 1000 rupees and 10% is the 10% is the transaction fee. So out of that transaction fee, maybe we get 10%. It's just a number, we have to see it. So we get 10%. So here we have the 100 rupees of since there are 10 transactions, 10 into 10, 100. So we have 100 rupees as a reward in here, proof of stake. And the proof of work, after we mine each block, the miner gets 12.5 Bitcoin. So 12.5 Bitcoin means we get since $30,000 is around the price of Bitcoin as of now, so 30,000 into 10, so we get a lot more money if we get to mine Bitcoin. But here, since the initial cost is also low, the rewards are also low, and these are recurring rewards. So once we get basically voted or randomly, we get to choose randomly. So if we get randomly chosen, so here are the rewards, and we don't have to spend also that much, because obviously we have to just take 32 ETH, and 32 ETH is not that much, since as of now, since ETH is around $1,500, so 1500 into 32, it would be quite less than what we will incur here, and it's a one-time investment. So that is that. And here we have to pay also the secure electricity charges. We will compete every time. Here we have to compete only one time. We have just staked, and then we are allowed for being chosen. But here we have to constantly, if we don't get to mine, if we don't get the first time, we have to try another time till we get the reward. And then also we have to go on, we have to bear the electricity charges every time. But here we don't have to do that. So this is that. One more thing, in the proof of work, it is also expensive because we have to maintain our equipments. The equipments generate a lot of heat. We have to see for the heat also, and we have to see for the if the equipments are not working or not. But here it is comparatively very low cost. So what are the goals of proof of stake currency? So the proof of stake mechanism, the proof of stake is designed to reduce scalability and environment sustainability concerns surrounding the proof of work protocol, since it is very energy hungry. So the proof of work is competitive approach to verify transaction, which naturally encourages people to look for ways to gain an advantage, especially since monetary value is involved. Bitcoin miners earn Bitcoin by verifying transaction and blocks. However, they pay their operating expenses like electricity and rent with fiat currency, which is the local currency used in the area. So what's really happening then is that miners are exchanging energy for cryptocurrency. So they are paying for the energy and they are getting the cryptocurrency as a reward. So the amount of energy required to mine proof of work cryptocurrency profoundly affects the market dynamics of pricing and profitability. There are also environmental aspects to consider, since proof of work mining uses as much energy as a small country. So there is that. So it is that power hungry. I told you it's world's 0.3% of electricity goes into Bitcoin mining only, which is the proof of work. So the proof of stake mechanism seeks to solve these problems by efficiently substituting staking for the computational power, whereby an individual mining ability is randomized by the network. This means there should be a drastic reduction in the energy consumption, since the miners can no longer rely on the massive farms single purpose hardware to gain an advantage. Yeah, that's another main point, that in the proof of work, if you have a lot of money and if you have a lot of power, you can basically outperform the competition by building huge farms, huge systems, by combining a lot of graphic GPUs together to mine and gain an advantage. But here, since you are just staking a amount, so it is a random thing. A random computer chooses a random person, and the probability is almost same. I mean, it differs. If you stake more, you have more chances, but then also it does not give that much a bigger disadvantage to a normal person than as compared to the Bitcoin. Like, a normal person cannot mine Bitcoin unless he has a lot of money, but in case of proof of stake, anybody can do who has a sufficient amount of money for 32 ETH. So the security of the mechanism. So coming to the security, the main security threat to the proof of stake cryptocurrency is the 51% attack. Anybody who is in Bitcoin knows the 51% attack. The 51% attack is when someone controls 51% of the cryptocurrency and uses that majority to alter the blockchain. In proof of stake, the group or individual have to own 51% of the staked cryptocurrency. So basically, it is a thing which looks possible in theory only. It actually cannot happen because to have 51% of such a large blockchain, you require tons and tons of money. So, and then also it is not a guarantee that you will be easily given away, you will not face any consequences. So the 51% attack is just a theoretical concept, but the 51% attack is still a concern. So what 51% attack is, if somebody owns the 51% of the blockchain, the respective person can change all the addresses and transaction details of the blockchain and basically hijack it for its own benefits. So it is not only very expensive to have 51% of the staked cryptocurrency. Staked currency is collateral for the privilege to mine. The miners that attempt to revert a block through a 51% attack would lose all their staked coins. This creates an incentive for the miners to act in good faith for the benefit of the cryptocurrency. So there is a mechanism to restrict a person from doing the hacking and attacking the blockchain, which is that every person who stakes is 32 bitcoins, who becomes a validator has to stake 32 bitcoins. So if a person has to stake 32 bitcoins and he has to gain 51% of the blockchain, he has to spend a lot of amount, and if he tries to change the transactions and he get caught, he would lose all that amount. Even if a single validator tries to do something, he would lose his 32 ETH. So that's the punishment that the ETH gives, is automatic. So to make good faith and the benefit of the cryptocurrency. So most other security features of POS are not advertised, as they might create an opportunity to the security to breach the security measures. However, most proof of stake systems have extra security features in place that add them to inherent security behind the blockchains and the proof of stake mechanism. Basically, it is not that easy to hijack and disrupt a blockchain, and especially the proof of stake. So it won't go anywhere, and it is quite secure in that way. So now it is a very interesting question that whether the Bitcoin can be converted into the proof of stake, since we already know that it works on the proof of work, which is very energy hungry. So what actually happens is, we will see. So it's possible that Bitcoin will change to proof of stake. It is possible to that Bitcoin can change to proof of stake. Ethereum began its existence using the proof of work and it is transition to proof of stake, but the process can take years to implement in an already established cryptocurrency. So it basically, what it means is that Bitcoin can shift to proof of stake, but it is not that easy, since it will take a long time to do all the back end things and convert all the ledger and everything to proof of stake. So we can safely say that as of now the Bitcoin is not going to shift to proof of stake. So that was pretty much it for my presentation. I hope you guys like it. Thanks a lot. And my name, just to reiterate, my name is Lavsas Deva and I am a student in Vellore Institute of Technology, Chennai. Thank you so much.